we're trying to integrate this function over this surface area. And the cool thing about the ds, if it's a spherical system, is that the ds is actually just going to be equal to the area, like the dA of the surface of the sphere, right? And so if you can remember what that was in spherical coordinates, it would be p squared sine of the phi, and then it'd be dp, d phi, and d theta. So we can start making this replacement in here. And of course, we're going to have to change everything else to spherical coordinates as well. We should remember that x is going to be equal to p cosine of, hang on. We should be able to remember that x equals p sine phi cosine theta. Y equals p sine phi sine theta, and z is equal to p cosine of phi. So we should try to set this up by using a triple integral, 1, 2, and 3. And then we're going to just take this, but we have to sort of parameterize that over here. So let's go p sine phi cosine theta, and then the z squared is just going to be p squared cosine squared phi. And we'll divide this by 125. And then over here, there's also going to be some other stuff because we have to do p squared sine phi, and then dp, d phi, d theta. Well, we could try to simplify this a little bit. So let's see. There's going to be a sine phi squared. So sine phi, and that's going to be squared. We've got 5 p's. There's a cosine of theta. Okay, but we've also got the cosine squared of phi. And I guess we'll have the cosine of theta out here. And this all over 125. And we're going to go d theta first, and then d phi, and then dp. And then we're going to try 1, 2, 3. Now for the thetas, well, we know it should go 0 to 2 pi for the thetas. The dp's are going to go from 0 to 5 because we know that the radius is 5, so 0 to 5. And then for the theta, well, for the phi, we actually have to figure out what this angle is here. So it's a little bit harder, but we basically need to set these equations equal to each other in this situation so that we get some kind of expression. Well, let's set z, which is p cosine of phi, equal to the square root of x squared, which is p squared sine squared phi cosine squared theta, plus y squared, which is p squared sine phi squared sine squared theta. It looks crazy, but these two things are the same. We'll just pull that out. So we get p squared sine squared phi, and then cosine squared plus sine squared is 1. So yeah, and then we can square root that. So we'll basically get that p sine phi is equal to p cosine phi. These things will cancel, and then you basically get that sine phi equals cosine phi. And when does that happen? When we have pi over 4 equal to the phi. So that's what we're going to plug in over here for that value. And now if we try to integrate this, well, let's try to integrate over cosine first. So the integral of cosine is going to be sine. So we have sine of theta. All the other stuff is just going to be waiting for later. But we're going to integrate sine from 0 to 2 pi. And, well, it turns out that that's actually equal to 0. So, well, the answer to all this is going to be 0. But yeah, it's good practice.